And we'll get started here. Okay, so can somebody remind us what the two-step process is for finding an inverse function? We did this in chapter 1. Took 2 steps. Oh, so disappointing. How do you find an inverse? Switch x and y. So the first step is switch x and y. Second step, solve for y. Okay? Now, we're going to be dealing with some inverse functions in this section. So in 3.1, we learned about exponential functions. We're now going to talk about logarithmic functions and their graphs. Okay? So we're going to start off with what I think should be some relatively easy problems. We're very good at solving problems like this. Like if somebody asked us, hey, what's 2 to the third? We know exponents really well. The answer to that is 8, right? If I said, what's 3 to the second? I need an answer for 3 to the second. I'm giving you the base. I'm giving you the exponent. Tell me what the answer is. The answer there would be 9. Even if I have a negative exponent, okay? This means 1 over 4 squared, so this means 1/16, right? Negative just means reciprocal. And even if I have something like this where I have a fractional exponent, remember the sign of the exponent, that tells us whether we need to do the reciprocal or not. This is the exponent and the 2 is the root. So this really means this is the square root of 16 to the first. Square root of 16 is 4. So finding the answer to each one of those problems is relatively simple. But what if we reverse that just a little bit? What if we were given the answer, but we're asked what the exponent is? That's slightly more difficult. So if I said 3 to what power equals 27, the answer is 3. If I said 7 to what power equals 343, oh, that's not a number we're very familiar with. So we might want to stop and think about, well, if I do 7 to the first, 7 to the first is 7. 7 to the second is 49. What about 7 to the third? 7 to the third is 343. So the answer on this one was 3, and the answer on this one was 3. The exponent on both of those was 3. Here, relatively easy to find. You probably reached for your calculator, or at least thought about it really hard to think, yeah, 7 to the third, 7 cubed would be 343. Okay? A little bit more difficult problem. How about this one right here? 16 to what power equals 4? Gave you the base. Gave you the answer. I'm looking for the exponent. What is it? It's 1/2. Now this is made easy by the fact that this is the problem right here, isn't it? So this is going to be 1/2 for the exponent. But what about this one? 3 to what power equals 21? 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. Yeah, it's going to be somewhere around 2.5. But in order to know exactly what it is, we've got to have, yeah. Oh, does it say 4? Okay. Change it to a 3. Still can't answer that, can you? 4 to what power equals 21? Wouldn't be able to get that. Okay? All right. So, the point here is, if we have a variable up in the exponent, we've got to have some different tool for working with this because these problems can get fairly complicated. Okay? Now, so what we do with this is we say, look, if we know how to deal with exponentials really well, it would be nice if we knew how to undo those. Just like when we learn how to square, it's nice when we figure out how to take square roots so that we can undo that process of squaring. Okay? And that's what we're going to talk about today. We're going to talk about logarithms and how they're related to exponentials. So if you look at this problem right here, there are 3 parts of an exponential expression. Okay, this number right here, as we've talked about before, is called the base. This number right here is called the exponent. And for lack of a better word, this is the number that it equals. Okay, it's the answer to that exponential. It's just that number. And we have a name for this. This is called exponential base. Whatever the base is, in this case, it's b. So I can recognize those 3 parts in a very simple example right here. 2 to the third equals 8. We can look at that, and just to our eye, we can instantly tell, you know what? That is a true equation. 2 to the third does equal 8. Okay, but there's another way to rearrange those three things, and we call it a logarithm. So I'm going to take those same three things, and we're going to rearrange it into a logarithm. So logarithms have bases just like exponentials have bases. So if the base here is b, the base over here is b. And where we write it is we write it a little bit smaller, and we write it subscript. A little bit smaller below the word log. We use the word log to indicate that we're going to write a logarithm. The base is written down below just a little bit and smaller. So we call that subscript. Okay? The cool part about this is the answer to the logarithm is the exponent. So I'm going to put an x right there. So I've got the base taken care of. I've got the exponent taken care of. What goes right here? The n. So the way we say this is log base b of n equals x. And I'd like you to say it that way, because if you call this exponential base b and you call this log base b, it will make much more sense as far as their relationship to each other. So again, this is said log base b of n equals x. Okay? So we've arranged those same three parts into a logarithm. So if I did this for 2 to the third equals 8, I would do log base what? Log base 2 of 8 equals 3. So you'll notice that the answer to the logarithm is the exponent that goes on that base to make that number. Okay, and I think if you remember these things, it's going to make logarithms a heck of a lot easier to work with. So these are two basic facts, two really important facts about logarithms that you want to lock away. A logarithm is just another way to write an exponential expression. That's all it is. Instead of writing 2 to the third equals 8, we can write log base 2 of 8 equals 3. It rearranges those same three things in what sometimes is a much more convenient order. Okay? And this is really important. The answer to a logarithm is an exponent. So all I want to do now is just work on this. We can change from exponential form to logarithmic form. They are just different ways to write the same thing. So we can look at this and we know that that's true. 2 to the 5th equals 25. Let's write it in logarithmic form. That would be log base 5 of 25 equals 2. For this one right here, it's going to be log base 2 of 1/32 equals -5. Now take just a second and pause and look at that. This looks really awful. Can we look at it in this format and can we understand, yeah, that's actually true. It does actually work that way. Okay? And this one right here, this would be log base 9 of 3. You sure? Yep. Equals 1/2. Because if I take 9 to the 1/2, I do get 3. In other words, if I take the square root of 9, do I get 3? Yes, I do. Okay, let's come over here and let's do a couple of these. This is logarithmic form. Now, if you can look at that and you can see that that's actually a true equation, that's great. If not, let's write it in exponential form. So this is log base 6 of 36 is equal to 2. What that means is 6, that's the base, raised to, the answer to the logarithm is the exponent, equals the number. Is 6 to the second equal to 36? Yes, it is. Let's do this one right here. The way we'd say this is log base 10 of 1/1000th equals -3. This would be 10 raised to the -3. Answer to the logarithm is the exponent, is 1,000th. Is that true? Yes, it is. And let's do one more. Same one we just saw, right? This would be 9 to the 1/2 equals 3. Is that true? And can you tell by looking now? Okay, we need to be as good at looking at logarithms and knowing what the answer is as we are at looking at exponentials and knowing what the answer is. Okay, let that cook for a while. We'll pick up right here on Monday. Please try and have 3.1 done when you come to class on Monday. If you have questions, make sure you email me so I know what they are.